Welcome everyone to this new preview tutorial of the Avgeek Life series videos. And today we are, as you probably guessed yourself, we are in the iFly 747 new version, the V2, the newest release from a iFly developer team. And this is actually a payware aircraft released some days ago. And we are actually seated into the virtual cockpit, as you can see. Some introduction information for you. First of all, my name is Paul, as usual. Who doesn't know me, actually, I was a member of iFly since iFly Forum, of course. Normal member since the 747 was released in 2010. Then I tried to help other simmers while actually flying the 747 itself, and I got the opportunity when the iFly 747 was entering in beta test to join and help the iFly developer team, being a beta tester and a member of the beta test team until the release that was a few days ago. You are actually seated in the virtual cockpit of the 747-400 General Electric version. As you know, we have also the Pratt & Whitney and the Rolls-Royce, but more or less the cockpit is the same, except for some information about the engines and a few systems that are slightly different. For example, the auto start is not present in Pratt & Whitney version, or the ignition switch is different in the GA version to the Rolls-Royce version. Anyway, what's that video for you? First of all, I will do a walk around the virtual cockpit, around that side of the aircraft, explaining you some of the features you will find on the iFly 747 and that actually you can play with during your long flights with the 747 in the future. Secondly, I will start up a normal procedure following the iFly normal procedure that is actually the same as the Boeing normal procedure. If you compare them with a flight crew operating manual amplified procedure, they are exactly the same, to show you how to actually start up the aircraft, set up the systems and prepare a normal flight during with the iFly. Then we will start the flight that will be actually a short, very short flight around Porto airport, Lima Papa Romeo, that is in Portugal. We are actually now in Porto airport at stand Sierra 1-2, that is the whole heavy stand present into Porto. Anyway, this flight will be just around the airport to show you some of the features of the iFly 747. Mainly, I want to show you a normal takeoff, an engine failure. We will do the procedure for the engine failure, and then we will do a prompt return to the airport at landing and taking off from runway 17, where there is category 2 ALS, so we will use an outland to show you how the outland is performing also with an engine out on the 747. This is mainly because during the beta testing, one of the focus points for the team was actually the outland. We had to report all the many things about the outland, and we actually improved the outland a lot, and is now perfect in all the cases. Other information for you. First of all, I'm flying the 747 into a laptop PC that is pretty low settings, so don't expect magnificent performance. I'm sorry for that. I'm not able to use a tower PC right now because I'm not directly home. Anyway, I hope you enjoy the flight, and I'm sure you will love the tutorial itself. You can jump towards the tutorial, so finding everyone you wanna try for. And first of all, I want to show you the virtual cockpit that is pretty amazing. First of all, we are in FS9 9.1, and this is actually what you will see in your virtual cockpit in Flight Simulator 9. As you can see, we are on the jump seat. You will find it, yeah, we are on the jump seat, and we are watching towards the center of the cockpit. In this new version of the 747, you will find a lot of animations, a lot of sounds, many things that users actually said about the 737 were actually put into the 747 to improve the overall experience. First of all, the sounds of the knobs. For example, if you go to the maintenance panel, this is the maintenance panel, and you move the knobs, you will hear the sound. The same for the guards, so hear that. Or the guards, as I said, that are actually closing themselves, or the button. Everything have its sound into this cockpit, and it's amazing. The details of the virtual cockpit and the aircraft itself are amazing. You will never find another aircraft in FS9 that is the same level of details, and this is probably because iFly was able to improve the standard polygon limit into FS9, and this is something incredible. You will love it, flying the 747 in FS9, because it's something amazing. I'm sure that in the Prepare 3D and in FS6 is the same thing, but as I'm a long story FS9er, I must say I'm shocked by the level of detail iFly was able to put into this model. Another information for you, I'm just using a beta version of the iFly, so maybe some functionalities, some features will be different from this version to the actual release. So I'm sorry for that in any case, but I'm sure probably all the features you will see here will make to the market. The only difference from this model to the FSX and Prepare 3D model is the miss of the weather radar, sorry. For the weather radar, of course, the weather radar requires Active Sky Next as in the 747, and so we will not be able to use it in FS9, but this is not a problem anyway. The weather radar panel actually is working. You can move the knobs, but they are dummy in the 747 in FS9. As you can see, the weather today is pretty bad. The reason is because with the bad weather and bad visibility, my performance are better on the computer, so sorry again also for that. I want to show you some sounds, of course. First of all, when you will be to the cockpit in the position, you will not be able to see the screens with the yoke, so we can move the yoke to the ground, put up and down to actually modify the height and watch to the screen. You can adjust the pedals, as you can see, and set your favorite position. You can move the armrest and also move the seats, and you will hear the sound of the electrical motor on the seat. This is pretty amazing. Check out the rails of the seats actually moving, and this is something amazing, really. Other things I can show you. I show you the sounds. You can see we have a lot of things around, and there is many things you can do in this aircraft to actually enjoy it. Oh, there are the handles to move the seats in the real life. You can move all of them, both on the overhead and on the main panel. And if you move to the right hand seat, I will show you two more features. So wait a second, we are moving to the right hand seat and show you a few more things I want to show you before going outside and showing you more feature of the outside of the aircraft. Okay, now we are in the first officer position, as you can see. This is the first officer position view of the overhead. Watch the definition of the details of the screens, of the switches. As I said, I am on a laptop, so I'm not using anti-aliasing at all to improve the performance, so I'm sorry for that, but as you can see, the details are pretty amazing, even in low details from the cockpit. This is the position, of course. Other things I want to show you is if you're flying on the Atlantic and you feel a lot of sun coming into the cockpit from the right hand seat, you can move the sunburst and the sun some protection. The same things here, and the same things go actually on the left-hand seat. You can close them. And there is also the sound coming down directly from the real cockpit, so this is pretty amazing. The last thing I want to show you before coming outside and showing you the outside of the aircraft is another feature we always waited for FS9, but was pretty incredible to be seen from the virtual cockpit because of the polygon limit until now. If we move this way and move outside, you will see the wingtip from the virtual cockpit. As you can see here, we have the wingtip of the aircraft showing pretty good to the side. There is also the light working and the slats on the leading edge flaps moving. You will show them, and they are pretty amazing during the flight to move everything and show and actually see the wings from the virtual cockpit. Something not habit in FS9. Of course, the FS6 and Prepare 3D are more habit to that. Now we will leave the virtual cockpit and go outside. So wait a few seconds, and we will talk about the outside of the aircraft and what's going on the outside of the aircraft. Okay, here we are on the outside part of the aircraft. As you can see, we are parked with the two fingers attached to the aircraft. The fuel truck is coming his way to the airplane, and what I wanted to show you is the details, of course, of the aircraft. As you can see, the model is beautiful. This is the standard livery of the iFly, but Colin, as you know, Colin Lowe is doing a massive amount of liveries you can actually add to the aircraft, and they are all amazing. We actually test some of the liveries, and amazing work. Anyway, back to standard things. First of all, I'm using airport enhancement service, but this is not important. The control group, as you can see, the elevator and the inner inboard aileron, they are actually dropped in this moment because the hydraulic system of the 747 is very, very complex. We have 4 different systems. They are actually driven by 4 different independent engine, of course, and every single surface has its independent source, so you can move any surface with a specific hydraulic system. If you fail, if you for example have a failure on a hydraulic system, you will not lose any flight controls, for example, but if you for example lose 2 hydraulic systems, you will lose some components. And for example, let's say some hydraulic system powering the inboard elevator actually failure, you will be able just to move the right and elevator, and the inboard will actually don't move at all. The same thing for the other controls and the nose wheel steering. The nose wheel steering, the nose wheel braking, and the boogie beam steering, because you will know actually the 2 inboard landing gear into the main landing gear, they actually tilt and caster around their axis to actually improve the steering capabilities of the 747. Any other things? Yeah, the lights are amazing because iFly managed actually to create lights with reflection to the ground, so you will see a lot of lights being reflected to the ground. For example, the red light on this side of the aircraft will actually reflect on the ground during the night and during the evening at sunset. And another thing is the doors. You can move any single doors independently. A difference from the 737, and this was actually improved from the 737, of course, and every door can be opened independently, and this can be done by via the SIMO menu into the CDU, and this was an improvement over the 737 that was actually required by the user. So actually iFly thought also about the possible improvements that the users wanted to see into the new release. Now we will go inside the aircraft, and we will start with the electrical power-up checklist. Then we will start the CDU Preflight, set our flight, giving you a briefing of the taxi and everything else, and then we will move actually to the normal procedure. Following the normal procedure, starting up the aircraft, pushback from the stand, taxi to the runway, takeoff, and show you some feature of the aircraft during the flight. One advice for you during the flight: probably you will not hear me so good during the flight because I tried to do some tests with the sounds inside and outside the aircraft while flying. The sounds of the engine is amazing and is too high for this microphone to actually set my voice and hear everything. So probably I will try to speak during the flight. Probably you will not hear anything, I'm sorry for that, but I'm sure you will love to watch me moving the aircraft and how the 747 works itself during the flight. So see you later into the cockpit and start up electrical power up checklist. Before starting the electrical power up checklist, I was thinking about showing you the 2D cockpit. We will use the virtual cockpit in this case, but I wanted to show you the beautiful flat cockpit of the iFly. That is amazing, really. The details also on these are amazing. The gauges are sharp and they are amazing. So if you go, for example, this is the captain VFR panel. You have also the first officer VFR panel. We have the captain IFR panel with the brake hydraulic pressure, the accumulator pressure, and the FMCs and the lower DU. We can go to the first officer IFR panel, the same as the captain one, but with the ground proximity panel. Then we have the throttle panel, the pedestal panel, or aft HELEC as is written on the iFly selector panel. Then we have the forward overhead, the aft overhead, that is also called the maintenance panel. And then we can open independently the PFD, the handy, and the upper DUs. The two CDUs, the one from the captain and the one from the first officer, and the compass one. This is pretty much everything you can move into the 747. Every switch is modeled in the 747, so you will find everything moving, everything having a function, and you will love it. I'm sure you will love it, as I enjoyed it during the beta testing, during all those long hours of testing, maybe 100 of them. Okay, now we have into the virtual cockpit, as you can see in the stand, parked and waiting. In the cold and dark cockpit, you the last thing before starting up the procedure is the sharp of the gauges. I want to show you the sharpness of the altimeter and the sharpness of the standby airspeed indicator. It's amazing. This is FS9. We never saw the sharpness on the gauges, and the same thing goes for the LCD displays. They are very sharp, very amazing in FS9, to be sure. At this point we can start the electrical power up checklist. Electrical power up checklist requires us to go to the overhead panel, and as you can see we are in complete cold and dark cockpit. First of all, we have to give you, the airplane some electrical power. Electrical power should be set up from the batteries. The batteries actually power up a part of the DC circuit, actually the vital or the hot buses of the aircraft. The hot buses, the DC hot bus actually, because it's DC source, are directly connected to the battery. They can't be they can be disconnected from the battery. So every time the battery is powered up, you will have the vital or vital or hot bus power to these buses. You can actually convert the DC power of the battery into AC power using actually inverters. Inverters can be powered up by the standby power selector. The standby power selector, when in auto position, actually senses the DC power output of the battery and open up the inverters to power up the AC essential buses. If the battery is connected and standby power is also in auto, also the DC essential bus will be powered up, and so we will have some instruments going on. With just the battery, you will have the standby instrument and the clock. This is actually the hot bus. With also the AC, the essential AC power from the inverters, you will have the left side of the screens, so the captain navigation display and PFD, and the upper view, and you will have also the left control display unit or CDU into the pedestal, but I will show you in a few moments. First of all, we have to start up the battery and check out that when it is on there is no off lights illuminated, so we open the cover and we turn on the battery. at this point the battery is turned on. If I go in the main panel, you will see that the clock is powered up, and also the standby ADI is powered up. As you can see, is in horizontal. The same thing goes for the altimeter and standby, but those instruments does not require electrical power themselves, so they don't need this. Second thing we have to do is to set standby power to auto, so we rotate standby power, and as you can see now we have AC power because all the lights are on, and we have the left CDU on. We should also have the left screens, but this is the realistic DU startup process, so we have to wait some minutes to warm up the screens before they come off. Now we have to do the security checklist. It's always in the electrical power up is the safety checklist to be sure nothing is moving and we don't have any problem, and so we have to check that hydraulic pumps are off, as you can see all of them are off, and that the system fault and pressure lights are all on in this panel. Then we go back on the main panel, we check the alternate flaps are off. As you can see, the knobs in the middle is off and the button is out. Then we check out the landing gear, the lever is down, and we shall also check the indication on the upper DU, but we will wait later when we start up the DUs. Then we have to check the flap position. As I said, flaps lever is up, flap position will be checked later. And then we go to the upper panel and set up the electrical power. First of all, we have to connect the bus tie. The bus tie actually make possible to connect all the buses together to have a cross connection between the buses. In this case, you see isolation light is on. We have to put them in auto, pushing all of them, and when they are in auto there is no isolation lights on, and this means all the bus ties are okay. Now we have to set up a power source for our aircraft. We have external power or APU power. In this case we will turn on the GPU, and later I will turn on the APU, showing you everything. In this case, as you can see now, we have the left display units in on position. If I can zoom inside on the upper DU, you will see gear is down and green, so we have checked the indication with the lever, and we have also the flaps indicator is up, the lever was up, so actually we have an agreement between the two things. Without a power source of electrical power up from GPU, APU or generator, you will see those two yellow X's on the left hand side, because the left hand side sensor for the trailing edge flaps are not powered up, and this indication of the flaps is not the normal one, is the secondary flap indication, because the flaps are in secondary mode. When the flaps are in secondary mode, they are actually retracted and extended with bleed air and electrical power. This is when you actually lose the hydraulic power. In this case, we don't have the hydraulic power connected to the aircraft. We have zero on pressure for now, and so we have the flaps in secondary mode. Anyway, for everything I will show you here about the systems, I'm sure you will find much more details into the operation manuals and into the tutorial itself. So please fly the tutorial more than once, try at least once, but you should do more than once, and after that continue and read the operation manual to go more inside the aircraft system. Back to our flight, we have to set up the ground power. So we go to the SIMU menu, next page, ground support, ground power, and connect. Back to the normal menu, we can go up on the upper side of the aircraft. We can check the we can also set up the screens for the ECAS, for the synoptic actually on the inboard side, but I will show you later. Anyway, as you can see now, we have the available light on in the external power switch. This means that actually the source from the external power is at the right voltage, at the right frequency for the aircraft system, in this case 115 volts and 400 Hz for frequency, so we can connect the external power by pressing this button. And checking out that the on-flow power is actually displayed on both external power and external power. At this moment we have the electrical power to the entire aircraft. In few seconds also the right hand side of the aircraft will be powered up. As you can see, the right CDU is now powered up, the central CDU is powered up, and the mode control panel have the display that are now connected. The last step to do into the electrical power up checklist is actually checking up the standby power system. This can be done pretty easily by turning the standby power knobs to BUT, that is the last position on the right. And actually this procedure serves is useful because you check out that in case of some problems on the AC power, you will have DC power converting to AC power by the inverter. So we can set the batteries. In this case, the battery is giving us power for powering the AC system. As you can see in the upper DU, we have battery discharge main and battery discharging APU. This means the two batteries are discharging because we are actually powering the AC system by the inverters, so we can get back to standby power to auto, and we have finished the standby power test and also the entire testing for the electrical power up checklist. We have finished the electrical power up checklist. Now we have to start with the preliminary pre-flight procedure. Preliminary pre-flight procedure is usually carried out by the first officer as the pre-flight procedure. In this case, we will, as the captain, we will left the first officer going outside into the rain to do the walk around, and we will just move along the checklist and procedure to prepare our aircraft for the departure. The preliminary pre-flight procedure starts with the IRS mode selector and alignment. On the 747 we have three different inertial reference systems, the left, the center and the right, and we have two different GPS systems, the left and the right. The GPS systems are automatic, so you don't have to do anything for them. They are actually automatically turned on when you give AC power to the aircraft, while the IRS systems, of course, needs an alignment of around 10 minutes depending on the latitude. Usually in Porto is around 9 minutes. So we get the knobs, the left, center and right, and we turn them to nav, from the off position to the nav position. So we turn to nav, center to nav, and the right to nav. If you go back to the main panel, you will see that in the 747 we have the time to alignment into the navigation display, in this case 9 minutes for all the three platform, and the same RLS alignment mode is indicated on the upper DU or the ECAS part of the upper DU. At this point we have to select the status display on the lower DU. The status display is important because in this part of the status display you have all the messages that requires the minimal equipment list to be checked out, and in this case we don't have any message, so we are pretty okay. As you can see from the flight controls, there is the drop of the control in the aileron and elevator. This is actually simulated also in this display. We have to check out that only the expected messages are displayed. In this case, yes, we don't have any yellow or red message here because when you start up the aircraft, all the messages are suppressed until the startup, and this is actually a way to eliminate messages that are, of course, needed to be there. For example, engine oil pressure is probably one message that should be there because the engine is off, but in this case it's suppressed until the engine starts up to eliminate some distraction probably from the crew to the screens. Anyway, we have to check out the oxygen pressure of the crew and the passenger. As you can see, oxygen pressure is 1750 on both sides, and this almost full, so we are perfect. We have to check hydraulic quantity. As you can see, hydraulic quantity is 98% on all four systems, so we are fine with that. And engine oil quantity, we have to check out the engine oil quantity. Engine oil quantity can be checked out with the engine panel. As you can see, 17 quarters on all the four engines, so this is pretty much fuel tank, so we are okay. And we return to the status display after this. At this point we have to continue and go to the overhead maintenance panel. Now we are into the maintenance panel, we have to check some things about the maintenance panel. This procedure is done after a queue change or in the first flight of the day. You have to check all the guards are closed, as you can see: ground test, flight control, hydraulic power, generator field mine reset, split system breaker, and AAC maintenance and the fuel. All of them are closed. All the lights are off except for the SSB or split system breaker lights open. This is automatically moved by the system itself, so it's normal that it's open and the lights is on. And all the other lights are extinguished. We have to check out that the APU start source is Tango Romeo, is on the upper side. Yeah, it's not APU battery. We have to set up the lower lobe cargo conditioned airflow rate selector here. This means actually that moving this switch actually triggers some packs to move to iFlow during the cruise, and during the cruise, not the climb or descent, just the cruise, you will have air conditioning gear being delivered to the portion of the cargo lobe. In this case we have forward, afterward, both of them in the low air conditioning, or high conditioning, just one of them, you can select of them. In this case we can move, for example, to the forward one, just imaging that we have some cargo, some dogs or cats into the forward compartment, and we can set the low air conditioning in this case. We have to check the CVR testing. As you can see, the needle is moving, so that's fine. And we can also test this quick test lights. In the loop 1 they are okay, and in the loop 2 they are okay. RS lights is off and this is fine, and we can return to the main panel to continue our checklist, because the last thing we have to check out is the parking brake must be set. As needed actually, but must be set. In this case we can check out the parking brake is lever is up. This means the parking brake is set, and we are happy with that. Next procedure is preliminary pre-flight procedure on the CDU. So the CDU Preflight. First of all, I will set up the plan mode to show you the setup of the flight plan, and we will zoom on the CDU itself to show you everything. The flight of today will be just a Porto to Porto, so it's just a big circuit around the airport itself, as I said, but I will show you how to set up the things in case you are not going to do a flight. Normally flight is pretty standard. The route insertion is pretty easy to understand. You can check out into the manual and into the tutorial itself. Anyway, we can start up the procedure and we can set up everything. First of all, I want to show you, I want to tell you, we are going to start and take off from runway 17, and we will land back to runway 17. We will just follow a LAVPA 6 Romeo departure, and we will arrive on the LAVPA waypoint, and at this point we will join the standard terminal arrival procedure route of LAVPA 8 Mike. Both of them are RNAV procedure, and we will use an airplane after the to return to the airport. Before going into the FMC set, I want to show you some feature of the sim menu. The sim menu, you can set up the failures, you can set up save and load the routes and the panel style, you can set the pushback, you can set the ground support, the doors, of course, you can open and close the door. For example, we can open the entry 1 and the entry 2. As you can see, main entry opening. And you can also move all the doors in the cargo and on the upper deck and everything else. And you can also set the refueling. You can refuel the aircraft from this menu, in case you want to actually set up any single tank or just the total fuel. And you can also do the payload in case your FSX in FS9 is not working. And after that, I want to show you the testings, but we will do that later for the confidence test. Anyway, you have the CMC, that is the central maintenance computer. If you go there, you can check, you can do all the ground testing you want. We have plenty of them. If you enter in one submenu, you have other ground testing just in the 737. You have ECAS maintenance page, for example. If you want to check out the HES, we can display it. You can see HES maintenance page. or the flight control display maintenance page, or everything else you can we want to check out. We are going back to the start page, and everything else. Actually, you can really modify everything and test everything. The confidence test is actually the stall testing, the GPWS testing, and the takeoff warning testing, and we will do them later after the IRS are aligned. And this is actually where you can find them instead of going to the maintenance panel like in 737, where did you have the stall warning testing and overspeed testing. Anyway, coming back to the menu, we can go in FMC. You can see item traffic index, selecting item page, and we are in the item page. Item page, you have to check the model is correct, the engines are generally correct, the hierarchy is correct, and the code data is Jefferson 1410. It's just actually it just we are in November, but that's not a problem for now. Drag full flow indicator coefficients are 0, and the op program is 2. One thing I want to show you before going there is the maintenance page. In the maintenance page you can do many other things, just like monitoring the IRS performance or modifying the performance factor of the 747. One of the things you will find while flying the 747 is in the standard one, in the standard 747, there is no automatic crossover between the climb thrust to the cruise thrust. When you arrive to the cruise, the throttle reference will remain in climb. This is exactly as in the same as in the real life. The only difference that you can modify these parameters in the per factor page by modifying this THR, CR, Zeta, or cruise to cruise /100. You can do that by modifying the page. First of all, you have to harm the page. So you have to write harm and set into the 6 Romeo LS key, and in this point you can actually change between climb, cruise, or modify every other parameter you can find. Maneuver margin at the stall buffet is 1.2 G. Minimum cruise time is 1 minute, acceleration 8, the standard values, the throttle reduction standard value. You can modify everything, and the takeoff 1, takeoff 2, thrust, and everything else. Anyway, I will not modify anything now, we will just use the standard one. This is the item page. We can go to position initial. We are in Lima Papa Romeo, so we can select Lima Papa Romeo and reference airport. We have the position. In this case we will use the GPS position to set the IRS position. As you can see, UTC time is correct, is 0811. You can check out with the clock is 0811, and you can check also the data 2014 and 08 November. So we are fine. We can go back there. In the second and third page you can also have other parameters, for example RMP and actual performance, and we can go there and check out the GPS position. You can select one of those two, but we will use the GPS position and set the IRS position. As you can see now, the IRSs are aligned. The IRS 3 is indicated here, so the aircraft is using GPS receiver and IRS platforms to find the correct position, and we don't have anymore the IRS in alignment indication. Now we can move to the route page. As I said, the flight is pretty standard. It's Lima Papa Roma to Lima Papa Roma, so we'll set LPPR, and again LPPR to the right side. The flight number is iFly, just to be original, 005, and we set the flight number. We don't have any company route. You can actually set up the company route in case you have one saved previously from the save option into the SIMO menu. In this case we don't have, we just select the route. It is pretty standard, is LAFPA, Lima Alpha Victor Papa Alpha to the takeoff. And as you can see now, we have the LAFPA waypoint indicated here. And this is all our route, so we can activate the route and execute it. Of course, we have just the inboard leg. We can go now to the departure arrival, and as we will start from runway 17, we select runway 17, and then we have to find the LAFPA 6 runway departure. Here we have. As you can see, the procedure is loaded up. We can execute the route now. Now we can get to the index, and we will select the arrivals. So we select LPPR arrivals. We expect to arrive using the LAFPA 8 Mach arrival to runway 17, as you can see, and we select the ILS 17. We will not use any transition. Actually, we can use the Porto transition because we have the holding path, and we will probably use it just to show you how the aircraft flies into an holding pattern. And now we can go to the next page before executing, because we have to modify the route itself. I just decreased the zoom because we have to modify the procedure here. We have Hadrub, and then we have POR and CI17. CI17 is here. We actually have the Porto hold at 3000 feet, so we can modify the route to make it straightforward. We have to actually eliminate Porto itself and the Porto holding, and we can select CJ17 to put it there. We will actually have to do an holding later and Porto NDB maybe, so we will be able to enter the holding later, and I will show you how to do that. We can execute the route now, and we are ready to check out again the legs. Is Xapim, Lavpa, PR611, PR671, Udrub, everything else, that's fine, pretty fine. The only thing is that we will actually join the glide path in this waypoint, Charlie India 17 at 2,400 feet, and then goes down to the glide path from the ILS. We can return to the route page now and set the alternate airports. In the alternate airports page, you can select, those are actually in low, in small letters. Those are actually automatically selected. You can make it manual, selecting, for example, this is Porto, selecting Lisbon, for example, Lima Papa Tango, and start on the first line. Or you can select, for example, Santiago, that is also into the list. As you can see, we can select it, and now we have two alternate airport into the selected. If you can actually zoom out, you can see those alternate airport being indicated with a blue circle and an A into the middle. We can now return to 5 and get to the map. If you can see, we have just selected an approach. We are in the same airport of the approach, so we have the localizer aligned, and if you can see, the updating of the position of the IRS is both IRS 3, so 3 platform, GPS and localizer, because we have the localizer too. We go to the route page, and we go to the performance initialization page. Today we have 100 tons of fuel, 104 tons of fuel actually, just to get a good weight for the departure, and our zero fuel weight is 179 tons. 8. We can select this in zero fuel weight, and we have the gross weight that is 24.1, exactly as expected. Reservist for today are more than 50. We will just select 50 as a dummy figure, or no, 500, just 50, and our cost index will be 150. You can select any cost index that is between 0 and 999. Cruise altitude for today will be we will use 8,000 feet cruise altitude, and we will also use cruise CG is around 28. We can select 28. This can be actually left blank, it's not important, and the step size we will left ICAO, but we will not do any step climb during the aircraft. ICAO step size is actually 4,000 feet, while if you want to modify this, you can enter, for example, 2,000. And actually step climb 2000, putting into LSK5 Romeo. We can now go to the thrust limit. Today we have a long runway and there's low weight, so we can use 70. And actually we will use takeoff 2, the rated takeoff 2. I know actually that with contaminated runway we should not use selected temperature anyway. We just think to have rain today, and so we can use it. After that, you can go to the takeoff page and set up the takeoff page. Today we will use takeoff flaps 10, departure with an acceleration rate of 3000 feet, not 1500, so we can select it. Engine out acceleration rate is 1500, is fine. Throttle reduction, we will use 1500 and set. Wind today is, we have an headwind of 5 knots, and this is HD5, and we have a runway that have a slope of plus 0.2 in this case. Actually, you can set the slope. The U means the uniform actually means up, so it's a plus. If you want to go a slope that is minus, you have to enter a delta, is a down. You can set wind and slope. Now we have the reference V1 is selected, 132, 145 for the V rotation and 159 for the V2. The center of gravity in the 747 is automatically selected, so you can actually press the button and you will have a center of gravity selected. In this case is 28. We have a planning 28.4%, and you have also the trim figure we will need during the runway. Position shift, we don't need any shift of position. You can actually modify this in the iFly in case you are not taking off from the very end of the runway to actually change the values of the reference speeds, and also for the updating IRS position when you actually set up the toggle. Before moving to another section and actually finishing with the procedure and finishing with the takeoff ref, I want to show you a pair of more pages into the CDU that are probably more important because they are different from the 737 we're ready to fly. First of all, to change the transition altitude and the transition level, you must go to VNAV page, and as you can see, transition altitude for climb is indicated into the climb page, and if you go with next page, you would descent forecast like in 737, the transition level is in this one. The other thing is the navron page. One of the main differences between the 737 and the 747-400 is that the radio VHF, the radios VHF for navigation are actually set up with also the ADF into the CDU directly. You have two VOR receivers and transmitter, VOR left and VOR right. You can select the course and the radial in case you need. Two ADF transmitter and receiver, and one ILS indicator. In this case, the ILS is displayed in lowercase a because it's automatically selected as the radius, and is also, as you can see, indicated into the primary flight display with the required information. You can select another frequency or per selecting another frequency. In this case, for example, if we go and select stations, we can select another VOR, for example. We have Victor Golf Oscar. We can go down here selecting Victor Golf Oscar and maybe inserting in the second radius, and as you can see is manually tuned. If you want to retune to automatic, you just press delete, and this retune to 110.60. Now we can retune to 05, and this actually complete our overview of the pages. There is also the possibility to check out the position of the aircraft instead against the FMC calculated position. As you can see, as I said, actually log GPS is used for position. As you can see, FMC position, log GPS indicated, and you have all the position in position reference 3 out of 3. Now we can return to takeoff page and continue with the preparation. We have finished the CDU Preflight. We can go to the right hand side and set the legs page. As for the takeoff is the standard one, takeoff ref on the left and legs page on the right. And we can continue our procedure by starting up the exterior inspection, of course done by our copilot. We can set up the lights, of course, nav lights are on, and we can set up also the logo lights for today because we have some bad weather. And if you go on, we can continue with the pre-flight procedure of the first officer, starting from the overhead panel in the upper left corner. First of all, you have to check out the engine auto start, which is on. this case is because in some 747 you have an auto start switch positioned over the electrical engine control. In this case we can just skip this passage. Electrical engine control switch must be in normal position and the alternate lights must be extinguished. We can check it out, all in normal, the lights is extinguished, the amber light is extinguished, so we can continue. Next one is electrical panel. Electrical panel should be set and we can check out. Standby power selector is in auto, okay, utility power switch powered, and so we have powered the utility buses and the gunley buses of the aircraft. Battery switch is on and the off light is extinguished, on and light is extinguished, and it's fine. Booster switch is in auto and isolation lights is out and you can see is extinguished, that's fine. Generator control switch is on and the off lights must be remain illuminated. They are on and the lights is illuminated. This is because they are actually disconnected from the engine at this moment. They are not running, and you also have to check that the drive lights into the drive disconnect switches is illuminated. Be cautious, because if you press one of those buttons, the generator will be physically disconnected from the engine, and you have to call the maintenance and the engineering part of the airline to reconnect the generator shaft to the engine accessory gearbox to make it moving. This is actually done because the generators into an AC system, in this case, actually have a speed control box that actually check out the speeds of the generator. Modifying the speeds of the generator is actually the rotor itself of the generator. If the speed is actually moving, increasing or decreasing, instead of the 400 Hz that you should have of frequency, actually if the speed is modifying and you can control the speed, you risk to have too much current into the system, and too much current, as probably you know, will damage all the electrical system with a lot of heating coming on, some fire possible coming up, so it's pretty serious. In case you lose the control of the speed of the generator, you have to disconnect this generator themselves. In this case we have the off lights on and the drive lights on, just because the generator is now not online, because the aircraft waits to have a proper N1 rotation to give set up the generator and put it in online, and just because we have the engines that are off, so it does not sense any speed on the generator itself. At this point, as I said, generator control switch is on and checked, and the drive lights are checked. Now we shall turn on the APU. As you can see, the APU is here. We have off, on and start position, and this spring loaded to on. We can so select to start position. As you can see, the main two aft pump and main three aft pump are actually losing the press light, just because the two tanks actually have DC pumps that actually power up the APU to the APU feed line, and these are actually put into the main two aft tank. Anyway, the tank 3 is actually cross-feed to the second to maintain the balance between the two. If we go to the start page now, you will see the APU starting up. We have the APU line here with exhaust gas temperature N1 and engine APU oil quantity. Sorry. When the N1 goes over 95, you will see APU running message, as you heard. And we have now full N1. The EGT is stabilizing, so we are just finishing to start up the APU, and then we will connect the APU to the onboard systems to give the power. The EGT now is increasing again. Now it should start decreasing, and when we'll stabilize at 500, 400 EGT, we will have the available lights coming up on the APU Gen 1 and the APU Gen 2. Waiting for that, just some information for you. Did you ever ask yourself how an APU is constructed? An APU itself is it's not so different from an engine itself. It does use a free turbine engine. This means actually that there is some stages of the turbine that are not connected directly to the spool of the compressor. This means that the turbine is rotating, and the shaft coming out from the turbine can be used for any other sources. In this case, it's used for a generator, In other cases, a free turbine is usually used for helicopters. So the free turbine is not connected to the compressor, but is connected to the shaft that goes to the rotor of the helicopter. Anyway, now we have the available light. We can select the APU generator. The aircraft automatically disconnect the external power and connect to the APU while depressing the button. Next part of the checklist is this hydraulic system and hydraulic panel. We have to check the demand pump selector are all in off position. They are all in off position, and the system full and system press lights are on, as checked before. Engine pump switches must be selected on, and the press light must remain on because we don't have any pressure coming out from the pumps on the engine accessory gearbox, so that's fine. About the demand pumps themselves, the pumps are different. You have electrical power pumps in the second and third system, and the demand pump on the system 1 and system 4 are air driven. This means that sometimes, because they are driven, the fluid from system 4, if it is pressurized before the system 1, can mix the fluid between the two systems, system 4 and system 1. For this reason, we have an auxiliary selection on the demand pump 4, because we have an auxiliary pump of the auxiliary pump in the fourth system that is electrical driven. The aux pump is actually electrical driven, and we can actually select the aux pump just for ground servicing, because actually permits the ground servicing of the aircraft and the ground movement of the aircraft. And we will use also the pump 1 to permit the free castering of the nozzle gear steering strut. Anyway, as I said, we have an aux pump mainly because there can be any fluid mixture between the system 1 and 4. Anyway, the maintenance manuals are much better in explaining this than me, so if you want to check out the maintenance 747 aircraft maintenance manual in AMM, and check them out if you need some other information. Then we can move to the other column. Start up from the from here. We have the emergency light switch quad closed and in armor position, that's fine. Observe the system is normal, service interphone is off, and fuel transfer main info is off, as you can see, so it's fine. We should do the fire override testing. I just forget about it, because you should do this before starting up the APU, and you should do it after the electrical power up checklist. Anyway, I will show you now. If we go to the main panel and select the upper DU, you will see the fire override testing. You will see the red lights coming on, red indication fire override test in progress indicated, and when the test is passed, all the lights will be out, and a red light with fire test passed will be indicated on the upper DU. Test in progress. As you can see, lights are on. Now in a few seconds the lights goes out right now, and the fire test pass on the upper DU is indicated. You can release the button and the test is complete. This is everything from the really is pretty easy. At this moment, after fuel transfer main 1 and 4 switch off checked, and we go to the fire panel. Fire panel set, you have to check out all the engine fire switches are in, and this is checked. The bottle A discharge and bottle B discharge lights must be extinguished. Those two lights and those two lights checked. This is mainly because you have two different fire extinguisher bottles for each side of the aircraft. This means we have two bottles for the engine 1 and 2, and two bottles for the engine 3 and 4. For this reason, actually, if you have two fire in engine 4, you can use both bottles on engine 4, or you can use both bottles on engine 3, but those two bottles can't be used on the engine 1 and 2. We can go down. APU bottle discharge light extinguished. Here APU fire switch is in. Cargo fire discharge light is extinguished, as you can see, and the cargo fire arm switches are off and out. Okay. Forward and after lights are extinguished into the two switches. This is fine. We can move to the engine start panel. Engine start panel set. Start switches are all in. As you can see, the white light into the circle is not illuminated, so that's fine. Standby ignition selector is normal, that's fine, checked. Continuous ignition switch is off, and is off. Auto ignition selector is in single position, that's fine, and auto start switch is on. We will use for auto start. This part of the panel can change between engines because different engines have different system or different selections. In this case, the amplified procedure into the iFly is focused on the General Electric version of the aircraft. Fuel jettison panel here should be set. Fuel jettison selector is in off position and fine. And fuel jettison nozzle valve switches are closed and off, and the valve lights is extinguished, so it's fine. We can move to the fuel panel. Fuel panel, crossfeed valve switches set on. Check the valve lights goes out in a few seconds, and you can check out everything is fine. In case you receive a fuel tank to engine indication in yellow on the upper DU, this means you have to change the selection of the fuel panel. This is pretty advanced, so I will leave you for the tutorial anyway to give you a small insight about that. When you have the quantity of fuel that is in the tank number 2 is the same or lower than the tank number 1, and in the same way for the right side, so actually the fuel quantity in tank 3 is the same or is lower than the fuel quantity in tank 4, you can actually you have to modify the crossfeed valve selection by setting off the crossfeed 1 and crossfeed 4 and leaving the 2 and 3 on. As you can see, they are guarded for a reason, just for that. And you have to actually turn off the override pumps on the main 2 and main 3. Anyway, follow the tutorial, read the operation manual and the amplified procedure for the cruise. You will find all the information here. They are pretty straightforward. Now we have to check all fuel pumps are off. They are all off, and we have to check out the main pump press lights illuminated. That's fine. The main 1, 2, 3 and 4. Of course, I said those 2 lights are off because we have the APU started up and the DC pumps for the APU are on. In fact, we have to check the override 2 and 3 pumps and center pumps press light is extinguished, as you can see, and the stabilizer pump press lights are extinguished, and this is checked. NTIS panel is set, national anti-ice switches are all off, wing anti-ice switches is off, and the valve lights for both of them are extinguished, that's fine. We have windshield protection panel here, we have to set up. Windshield you can set on and check the inoperative light is out, and the windshield wiper selector must be in off position, they are in off position. We now can move to the lighting panel on this side and check out landing light switches, runway turn off light switches and taxi light switches, all in off position, and this is cross check. The next part is on the last column of the 747 override panel. As you can see, we have the passenger oxygen guard switch, must be guard closed, and do not open it because if you move to on, it will actually release the oxygen mask in the cabin, and the oxygen pressure will decrease slowly until to F0, and you will have some indication of the upper DU for that. You have to set the yaw damper to on, and the inoperative lights should be on because the yaw damper are operative just when the hydraulic system is pressurized and the IRS are aligned. So we have the IRS but not the hydraulic power for now. Cabin altitude panel, check the landing altitude is in auto. You can check from it, actually you can check that the button is out. If the button is out, you have the landing altitude in auto. Anyway, you can check out by going to the engine panel, for example, and check out the landing altitude. Here you will find 250 auto, and this means you are in auto. We can go back to the start page and we can return on the override. Coming back to the cabin altitude panel, you have to check hold flow valve manual switches in off, these two are in off, and cabin altitude auto selector in normal, and this is checked. Hold flow valve are open, and this is fine, and we can move to the ACS panel or environmental control system panel here. Passenger temperature selector and flight deck temperature selector in auto, they are vertical switches in auto. We have to select trim air switch on, and at this point we have the zone system fault light extinguished because we have turned on trim air. This is actually normal. We select upper recirculation and lower recirculation fans to on. After cargo heat switch will be set off until after startup, because in this way some bleed air will be taken from the compressor, and this means less power and less air for the startup. Anyway, so we will leave it off. Emergent equipment cooling selector is normal, of course. iFlow switch is off. Gas burn switch and humidifier switch are both in on position to improve the air actually coming into the cabin for the people seated to the cabin. One indication for the humidifier, you will probably notice if you've flown a lot of aircraft that humidifiers are not common into the aircraft. This is because after the air exit the air cycle machine, so the pack itself is very dry. The aircraft, the air outside the aircraft at flight 400 is probably have a relative humidity of 2% to 3% or something like that. So when you release the aircraft into the cabin, you should actually improve the humidity of the aircraft, of the air itself, anyway, to around 40-50%. Anyway, the humidity is not modified usually in the aircraft, because if you increase the humidity, you can actually create corrosion problem on the airframe itself. So usually into the aircraft the humidity is not controlled. The 747 itself is pretty different. You have an humidifier into the system and actually improve a little the situation. Anyway, humidity will never be near 40% into a real aircraft. So if you feel dry, if you feel your lips dry during a flight, now you know why, because the air is too dry into the into an aircraft flying at iFly level. Just a curious point to do that. Anyway, continuing to the bleed air panel. Bleed air panel, pack system full light is extinguished. Pack system full light is here and is extinguished. Pack control selector, all three normal. We can select only normal. Normal is automatically, and you can see there is also two controllers per pack, controller A and controller B. In normal position, actually the controller is automatically selected, usually on the A1. Left and right isolation valve open, and the valve lights is extinguished and checked. Engine bleed air system fault light again is extinguished. We checked again. Oh, sorry, it's different. Engine bleed air system full lights are those four lights here. They are extinguished anyway. EPU bleed air switch on. We can select it on. The EPU is on, and you should hear the sounds coming up. Probably the sound is not here so much in the video because I'm using low sounds to make possible to you to hear me talking. Now we have the EPU selected. The valve lights is on. Is off. Sorry. Engine bleed air switch is all on position. Last part is lighting panel. It must be set. Beacon lights off. Nav lights on in case is needed, in case on. Stop lights off. Wings lights off. Logo lights as needed, in this case on. At this point you should test the overhead light panel and every light indicator on the panel. Unfortunately in VC it's pretty hard to control all the lights by this switch, because you actually return to normal position. Anyway, if you press it, you can see all the lights are coming up. You can check out all the lights also in the main panel, then release the button and come back to the normal. We now have to return to the main panel. As you can see, now we are in the main panel and we have to start from the glass shield panel. Flight director switches must be set on. Flight director left to on, flight director right to on, and you can see flight director indication are indicating FMA. Status display must be selected. We have selected the status display, and the AFIS control panel must be set. AFIS control panel, we have to select the minimums. We will left them in radio. Actually, you should set on barrow and select the barrow altitude for the departure. Usually is the safe altitude. We can leave it at 500 feet, or we can usually improve, increase or decrease depending on the situation. We can set the flight path factor on. The meter switch as needed, in this case off. Barrow, we set each hectopascal and we set the actual hectopascal 1013. So it's set. VOR ADF switches as needed, in this case both in VOR set, and the selector in map mode. Center switch as needed. You can set the center as you want. We will have off, and the range selector to 5. Traffic on. And this is finished. And map switches, of course, you can set all the map switches you want. For example, station, waypoint. There is also the dummy switch in FS9. You can set up the weather radar. You can modify even the tilt, but it's a dummy. And you can also have the terrain in case you want to see the terrain of the zone. In this case, 001, 006, and this is the peak mode. But we will leave it off. At this point, you should check out the oxygen mask here, and do the testing of the oxygen mask and check out the oxygen pressure. That is fine. So crew and passenger oxygen pressure is checked on ECAS, the pressure is adequate, and then we can go to the source select panel. Source select panel, we have to check out that all the sources are on the left. In this case, you can it's pretty easy because you have to have all them in vertical. You have flight director on the left side, FMC left, EU is in auto position, IRS is in left, and air data computer is the left one. If you modify one of them, you will have a failure. For example, if you select both the same source for both sides. For example, for the FO, air data computer is right, and we are in left. If we can modify to the right, you will have source selector air data computer into the upper view. We will leave on the left one. The same goes for the flight director, source selector, flight director. While you select the center one is the auxiliary one or the standby one, so you will not receive any failure because the two sides of the aircraft are powered by different flight director computer or by different air data computers. Anyway, this completes our source select panel check. The clock is checked and set. CRT select panel, you select the CRT. Invert CRT must be normal, lower CRT must be normal, and both are checked. If you didn't finish the CDU Preflight checklist, you have to finish the CDU Preflight checklist now and check the IRS line by this time. And you can continue with flight instrument just because of that. Flight instrument, you have to verify indication are correct, and the indication are correct. And you have to check out the flags. The flags can be TCAS off in the ND if the TFG switch is pushed, and it is pushed, and the TCAS is off for now. And also no V-speeds indicated if takeoff V-speeds are not selected. In this case we have selected V-speeds, so we have V1 132. And we have to check out the flight mode annunciator in flight director, blank, toga and toga. This is the standard selection for the takeoff. And we have to select the display in map mode. This was done actually previously. Ground proximity panel is on the FO panel. We can move there to show you better. A ground proximity panel, you have to check out that is set. We have the ground proximity light extinguished at all. The ground proximity light is here. Ground proximity flaps override switch is off. Flaps. Ground proximity configuration gear override switch off. Sorry for the break. I was watching the spelling of the gear. I just found the bug to report to the team, so later I will report properly. Anyway, and the terrain override switch is off. This is fine, and so we can return to the main panel, and we can check out the alternate flaps and gear. Alternate flaps, we must check that the landing gear lever is down, that the alternate flap selector is off, and the alternate flap arm switch is off. And you have to check also that alternate gear extend switches, both of them are off and guarded. CRT brightness controls, those two you can actually set up and modify them, as you can see. You can modify, we will leave it to full brightness. You have to check out the EAU selector is in auto, EAU selector is in auto. Heating reference which is in normal, not in true, and FMC master selector is on left. ECAS display, check. Upper ECAS display is pretty much checked. We have primary indication consistent with the situation, and the exceedance are not shown, so we are fine. Lower ECAS display, we have to check the secondary engine display, so we have to select the engine display, and check all the information as into the primary indications, and then we can select the status display. At this point I want to show you some of the synoptics of the aircraft. I can open it because it's easier to use the button on the 2D panel. This is the electric one. Then we have the stat one. We talked about the stat one. With the electrical one, as you can see, we have the SSB open, and the lights in the maintenance panel was open. We have APU 1 powering the boost 1 and the boost 2, and the APU 2 source powering the bus 3 and 3. We have the ACS. As you can see, the APU is powering all the 3 packs in A controller mode. The temperature is set on 24 master, and all the compartments in the aircraft are fine. You have the duct pressure in PSI. And you have also indication for the wing tank, wing NTL NTIs, sorry, wing NTIs and nacelle NTIs for the engines. At this point you can go also for the doors panel. You can see entry 1 and 2 are open, and there is a yellow box there indicating this. You have the door, the fuel panel. Fuel panel is now shut off, all the pumps are off, so they are off. You have just the cross-feed valves that are open, as you can see, 1, 2, 3 and 4. You can go to the hydraulic panel. Hydraulic panel is probably the most beautiful one from my side. You can have the more option, of course, of screens. In this case, as you can see, we are using the LCD screens. You can also select the CRT screens anyway. There is few changes, for example, the heating bug and some more things. At this point we have the 4 system. As you can see, the aux pump just on the 4 system. We have the reservoir pressure indication, because the reservoir pressure is not pressurized at the moment. As you know, actually the reservoir for the hydraulic system is pressurized at a few psi, actually around 50 to 100, usually is lower, is around 50, to improve the positive full flow from the reservoir to the pump, because you must provide to the hydraulic pumps must have a positive fluid to prevent cavitation, and so pressurizing the reservoir itself improve the positive full flow from the reservoir to the pump. You have to check out the pressure, quantity and temperature, that's fine, and this is actually the surfaces or the steering you can't use in the aircraft because of the losing of all the system. In this case you can't move anything because everything was off. Anyway, when we'll turn on any system you will see more and more flight controls being possible to be used on the aircraft. And the last one is the gear synoptic. With the pressure of the tires, you will see the pressure moving between flying at high level, low level, after landing with an high temperature of the brakes and so on, and 0 into the tire is the brake temperature. You have also indication of the gear doors, and this is pretty much everything you can show you on the synoptics. Continuing our preparation for the aircraft, we have to go to the pedestal panel and check the left radio tuning panel. Sorry for the visibility. Anyway, we have to check out the left radio tuning panel is set. Left radio tuning panel is set. As you can see, you can modify everything. You must check off that the off lights is off, because if you have off, the panel is completely off, both the audio control and the selector. Central radio panel is the same thing, is down here. You have to check out that the off lights is extinguished. Passenger sign, check, they are both on. You can see and hear the sound. The flight deck door is locked. Auto brake selector is down here. You have to select on RTO for takeoff. Right radio tuning panel is set, and check that the off lights is extinguished. As you can check it out. First officer audio control panel is as desired. Transponder panel is set, and we can now test the transponder. Actually, we can set. We don't have ATC, so we will set 2000 for uncontrolled airspeed, and we can test there. You can see a 4.8 indicated, and in the main ID you have the indication for the TCAS test. TCAS test is indicated in the navigation display, and you can hear the voice now.
TCAS system test OK.
Okay, the test is completed. At this point we have finished the pre-flight for the first officer done by the captain, but this is not a problem, and we will start with the pre-flight procedure of the captain. During normal zoom, the pre-flight of the captain is much shorter. You have to check out the IFIS control panel on your side. Again, we have just checked this. Anyway, you have to check out minimum reference selector to radio or baro, minimum selector set to decision 8 or altitude reference for departure, flight path vector as needed, meter switch as needed, barometric reference, barometric selector set, VOADF switches as needed, ND mode selector map, ND center switch as needed, ND range selector as needed. ND traffic switch as needed is on in this case, and map switches as needed. Then we move to the mode control panel. This is something we have to do. We have to select flight director switch on is on yet before, auto throttle hub switch is on, bank limit selector is in auto as you can see, and autopilot disengage bar is up. Oxygen, we have to check out again the oxygen. You should check also the right hand side of the oxygen and the status display. Status display is cross-checked more times to be sure the oxygen is there, and we have to note the oxygen pressure. Source select panel, again we check out all the sources. In this case we checked flight director, navigation, EU, IRS and air data all in left, EU in auto. Clock is set, CRT select panel is set, inboard, normal and normal. Again, you have to finish the CDU Preflight at this point. If you didn't finish yet, you check the instrument in the same way as before, so you check our indication are correct and takeoff and novice speed flag, and you check again the flight director FMA indication blank toga with flight director, and we display the map mode. Auto brakes must be on RTO, so we can check it out. Auto brakes are set on RTO. Standby instrument must be checked. Altitude indicator caging control is pressed, and we are checked is horizontal. ILS selector for the ADI is off. You can, as you can see, select for the ILS if you need it. And we set the standby altimeter on 1013 is actually set. Speed back lever is down and checked. Reverse thrust levers are down, and that's fine. And forward thrust lever or main thrusters are closed actually in idle. Flap lever is set up, and the same thing for the indication, so agreement between them. And parking brake is set on with the parking brake set message set, as you can see. Is not here because we don't have the pressure anyway. You should have the message shown this after setting up the parking brake, and you will see parking brake set message here. Fuel control switch is all 4 in cutoff, as you can see. Fuel control switch 4 warning lights are off. There is red lights inside the cap of the switches. You can check it out. That is off. Then you can move to stabilizer trim cutout switch, guard closed. Alternate stabilizer trim switches to neutral. Captain CDU control panel is set, and pre-flight checklist must be called now. Before start checklist is the next one. Before going for the before start checklist, I will show you the confidence test you can do here. Confidence test, CMC confidence test. You have the stall left, stall right, takeoff warning, and GPWC. That is the ground proximity warning computer is right. It's not GPWS. It's normal. Anyway, starting from stall left. Going for stall right now. Passed, that's fine. And takeoff warning, you will see all the takeoff configuration warning on the upper DO too. That's fine. And the last one is the GPWC. I will show you the navigation display while doing our testing.
Slide slope. Pull up. Wind shear, wind shear, wind shear. Terrain, terrain. Pull up. Sink rate. Pull up. Don't sink. Too low, terrain. Too low, gear. Too low, flat. Slide slope. Bank angle, bank angle.
Approaching minimums. 2,500. 1,000. 500. 400. 300. 200. 100. 50. 40. 30. 20. 10.
Wind shear, wind shear, wind shear. Too low, terrain. Caution, terrain. Caution, terrain. Terrain, terrain. Pull up.
As you can see now, the test is pretty much finished. We have just to wait the system to reset itself. And in a few seconds, I hope it will finish. Ta-da-da. Yeah, it's longer than expected actually. Anyway, it will finish in a few seconds. You see passed and the indication are off. So confidence test completed for the first flight of the day, and we create return here on the CMCR menu. You can check out the present lag fault in case you have any problem and the status messages during the flight, and you have also a second page where you have the existing fault and for example the fault history of the aircraft or other function possible. Coming back to the CMCR, we will left them here, and we can start the before start checklist. Before start checklist starts with the CDU display line must be set, takeoff platform left, legs on right, that's checked. The MCP must be set. You have to set up the YASMAX selector to V2. V2 is 159 for today, so we set 159. LNAV and VNAV must be armed if you need it, and so we armed, as you can see, white indicated LNAV VNAV. Initial heating must be set. Initial heating is the runway heating, so we can set this around 174 if I remember. 176 is fine. And initial altitude must be set. We are at the cruise altitude of 8,000 feet, so we will leave 8,000 feet. Taxi and takeoff briefing must be completed. I will do a briefing now about the charts exiting from the simulator, then we will return here after the briefing, and we will just talk about just continue the flight and the before start checklist. Okay, here we are at the departure briefing, taxi and takeoff briefing. You have in front of you the charts of the parking in Porto, as you can see, Lima Papa Romeo and Porto, Portugal. We are actually a stand 7 Sierra 12. This is runway 1735. Runway 17 is just up here, and the standard route for the departure is actually pushing back into the standard Sierra 2, and then following Sierra 2, Sierra 4, Sierra 6 and Foxtrot inside the runway. The area is not visible from tower, so we have to have the marshalling during the pushback, and this will be actually done. And we will actually push back with nose to the left, as you can see, and pointing to the north. Going to the next chart, that is the general chart for Porto. You can see taxi routes, arrival, departure. Departing around 17 stand from Sierra 8 to Sierra 12, in this case is the Sierra 2, Sierra 4, Sierra 6 and Foxtrot. Coming back to the parking, you can see pushing back Sierra 2, Sierra 4, Sierra 6 and Foxtrot, and we will follow this particular route. And now if we go to the airport chart, we will leave the apron via Foxtrot, then we will enter into holding point Foxtrot, backtrack the runway to the end of runway 17, 180 degree to the backtrack, and then take off on runway direction 173 degree, as you can see here. The airport elevation is 227 feet, and we expect a takeoff run available of around 11,417 feet, or around 3.5 kilometers. LVP are in force. Actually, we have an RVR of 400 meters, so that's pretty fine. We have no limitation for the 747 itself. In crucial spot, we have to be careful while taxiing inside into the runway via taxiway Foxtrot, and the Hotel Sierra hotspot actually must be checked out when entering into the runway. Next we can move to the normal takeoff. During the takeoff run we will just call 80 knots, thrust set before the 80 knots, and when the actually FMA turns into old mode, and we will call V1, VR and V2. In case there is any problem with the engine, I will just close the thrust lever before V1 of course, close the thrust lever, deploy the speed brakes and check the RTO braking and apply max reverse. You have to check that the speed brake will be up and also that the auto brakes are actually in RTO mode and actually are being applied by the aircraft. This moment we can move to the AirNav standard instrumental departure. We will follow a LAVPA 6 Roma departure. As you can see, we will take off from 17 with the VOR Papa Romeo Tango 114.1 selected. We will just take off on the runway heading directly to Xapim. At Xapim we must be at or above 3000 feet. Then we will turn to the right on 263 degree, inbound Papa Romeo 633, and we must be at or above 4000 feet at this point. The climb gradient for today is fine, and so we will continue the climb without any restriction, and then we can continue on 263 degree to LAVPA waypoint, where we will finish our standard instrumental departure. Transition altitude is 4000 feet, as you can see here. We must contact port approach after the takeoff, and as you can see, our from the MSA up here, our minimum safe altitude is 2300 feet, and we must get to 2300 feet before joining Xapim, so along the runway heading. Initial climb clearance is flight level 70. In our case we have flight level 80 as initial, issued by the radar, and this is actually everything about the briefing itself for the departure. See you back in the cockpit, and we will just prepare the aircraft for the startup and for the departure. Okay, we have finished now the briefings, and we can complete the checklist before start. We have to select the doors to close, so we can go there and select the door to close by the CDU via menu, SIMU, next page, doors, and you can close them left, entry 1, left, entry 2. Go back to menu and CMC as was before. You have to check the doors, so you can select the doors panel. No yellow indication, so the doors are being closed. We have to require the start clearance, and start clearance is obtained, so we will start and request airport announcement service to prepare for departure and for the pushback, while we will finish the before start checklist. F6, and yes, I need the pushback to nose to the left, because we are starting from our 17. At this point we can continue. Start clearance has been obtained. We have the clearance to pressurize hydraulic system, so we go to the hydraulic panel up here. As I said, we have to pressurize first the system 4 to prevent any mixing of fluid, so we set on aux. You can see now park and brake have the hydraulic pressure. System fault lights gas out and is checked, and the press lights stay illuminated. This is important. Hydraulic pressure pump 1, 2 and 3 must be set on. Now I want to show you one thing about the hydraulic system. If we can open the hydraulic system, as you can see now we have less flight control that have failed because we have system pressurized. Usually for the pushback you just need the system 4 and system 1, so we can just pressurize system 1 and system 4 and leave the system 2 and 3 to less pressurizing other later. In auto position you have both lights coming out, and this is important. Then you have to set up the fuel panel, so we have
hold on as we prepare the aircraft for pushback.
Okay, they are preparing the aircraft for pushback. We go to the fuel panel As you can see now we have fuel in main 1, main 2, and we have more fuel on main 2 than main 1, so we have to select those override. We select main 1 on, main 2 on, main 3 on, main 4 on, and the override pumps all on. No fuel in center and stop, so we'll leave them off. You have to select the center fuel pump switches to on if there is more than 7.7 tons of fuel in the center wing tank. Then we have to select the beacon lights to buff. Now we check out. We have select buff. Okay, that's fine. Recalls.
Parking brakes.
Okay, the pushback is being started, so we can release the parking brakes.
Okay, starting pushback.
And the pushback is being started. Recall switch. We can check recall. No messages indicated except for hydraulic pressure system 4 because we are in AUX. Cancel switch done. Trim set. Stabilizer trim. Aileron. We will set the elevator trim later.
Left is clear. Right is clear. Okay to start engines.
As we are starting the pushback, we have to select a mode for TARA for the ground. We have the clearance for start up the engine. We can set up 2 packs off and we can start the power up of one engine. We select engine and we move to the inboard to have better view for you. An auto start is pretty easy. Oh, sorry, I just pressed L. Now you have all the lights coming up. Sorry for that. Anyway, we just press with 2 packs off. You can start up 2 engines per time. In case you need just to start 1 engine per time, you can just set up 1 packs off usually. But mainly they actually turn off 2 packs. In the case the temperature is very high, probably you need to turn off all the 3 packs to do a dual engine start at the same time. Anyway, you have to press the 2 button. You can see the white lights coming up, but the stars is not starting up until you set the cutoff to run. In this case, you see the parameters for the 2 engines. All temperature is set up, so you can select the 2 indicator to on. Now, as you can see, the entry is moving, and N1 will rise when the fuel flow is opened. Oil pressure is rising. Oil temperature will rise soon. Vibration is rising too. In a few seconds the engine will be started.
Reset parking brakes.
Okay, we finished the pushback, so we set the parking brakes. As you can see now, the engine are being started, and one is rising, AGT is rising, and electrical generator 1 and 4 are off just because, as you know, they just come online when the speed of the generator is fine enough. When the 2 button actually turn off because the engine is stabilized in a few seconds when they are okay. Now they are actually released. As you can see, we can start engine 2 and 3, so we can set 2 and 3 and set the cutoff switch to run. Okay, we are now starting engine 2 and 3.
For taxi, please wait for my hand signal on the right hand side. Goodbye.
Okay, we are waiting for your signal on the right hand side. Anyway, the engine is now starting. You can verify everything. The good part about the auto start is that it actually works by themselves automatically in case of a not start or a wet start. It's actually, or a slow starting, it actually shut off the fuel and prevents any problem on the engine, improving the capability of containing the failures in case of any problem. Now, as you can see, we are just started up the engine 2 and 3, and the engines are now started. Of course, generator waiting for the N1 to speed up before starting up. The engine are now started and almost okay, so we can go to the overhead and do the before taxi checklist. Before taxi checklist, APU selector to off because we have the generators now. Hydraulic demand pumps to all of them to auto in a normal condition. So now all the lights are out. That's an NTI is not needed. Aft cargo heat switch must be turned on. In this case, if we need, so we turn it on. Back selector back to normal, all of them. and flap selector must be set as according to the requirements. In this case is 10, so we select flaps 10. Flight controls must be checked. We select the start page for the last one, and we check all the controls. Of course, I'm not using a joystick today because, as I said, I'm using a laptop, so I can move the rudder anyway. I can move the elevator. They are fine, and the ailerons. As we have the flaps down, the outboard aileron is working. When the flaps are retracted, the outboard aileron is actually blocked and locked into position. This is because at high speed you can have too much twisting moment on the tip of the wing using the ailerons, and so there is an inboard aileron to be used when on high speed, and for the 747 the high speed is when the flaps are not down, so over 230 knots. We can now neutral the controls, and we have to blank the display to prevent any possible distraction. To blank the display, you just depress a second time the button of the page you are watching, in this case the start page, and in this case you can see is off. Transponder as needed is set on alt off, so it's on for the ground. Recall switch and the trim is missing. So recall switch is this one, recall, as you can see, and cancel, no messages, and the trim must be set to 4.3, so as you can see 4.2, and is 4.2, we can select the trim, as you can see 4.2 set up on the green band. It must be on the green band, and it must be at the right setting. Actually the green band is okay for the takeoff. You will be able to take off in the green band. If you're outside from the green band, you will not take off, and there will be a takeoff configuration message coming when you pull up the engine for the takeoff. Anyway, setting up the correct trim is the best way to take off, and the safest, of course. At this point we are ready for taxi, and we just need to turn on the taxi lights and select the parking brakes, off, and taxi. The 747 itself does not require so much thrust to taxi. If you will actually find out that in taxi actually pretty good on idle on the vast majority of low weights. Anyway, if you are at a maximum takeoff weight of 390 tons, you will probably need much more thrust than with a low weight, and this is pretty much good simulated by the iFly. Now, as you can see, we are just taxiing. There is a lot of rain coming down. I hope you will enjoy the takeoff and the flights itself. I hope the flight will be fine enough for you. Anyway, my main concern was actually to show you how to set up the aircraft for the B4 flight. And in this case we did it actually by setting up everything before the departure. Now we are taxiing to runway 17, keeping the speeds under 225 knots, because this is important, and we will continue our departure until the B4 takeoff procedure. When entering the runway, you have to set up the takeoff, the TCAS to the array, and you have also to select the strobe lights to on when entering the runway, because we will enter the runway, backtrack to the end of the runway, and do a 180 turn to align with the runway 17. And before takeoff, you have also to check out that the engine oil temperature is above the standard temperature that was there at the start. We checked out after warm-up. The warm-up minutes usually are 3 minutes, are fine with for the departure. So we had 3 minutes done, and so we are okay. We will take off after 3 minutes of the startup, so that's fine. We are now turning. One of the things you will find harder if you are heavy to the 747 is actually the taxiing, because you have to overshoot the turns in the 747. This is something I'm not happy to do, and probably you will find out yourself while flying the 747. That's pretty hard to do the right turns before the takeoff. The weather is really bad. We have a lot of water coming down. before takeoff checklist anyway is pretty standard. You have to check out the strobe lights are on, TKF array. Before takeoff you have to select the landing lights on, you have to select the runway heading, and then you just push takeoff, go around. There are two ways of taking off with 747. The favorite way in the flight crew training manual of Boeing is the rolling takeoff, so it means you don't stop before taking off because probably you have a better performance. Anyway, usually you have to sorry, I'm starting up the strobe lights, and I will select the takeoff TCAS to the main one before entering the runway. Okay, that's gone. We are into the runway, and we are now just going towards the end of the runway to take off correctly. That's fine. You will find anyway the 747 to fly beautifully. Manually is amazing with the yoke, and also flying normal and long haul is amazing. I just tried a lot of flights while flying with the 747. It was really a pleasure to fly, just like the 737 in manual is amazing. I was saying about the I forget about what I was talking about. Anyway, while taxiing you will find out, oh yeah, the rolling takeoff or the standing takeoff. If you are rolling takeoff is usually the standard procedure. You just arrive into the runway and then spool up immediately without stopping on the runway. In this case we will stop on the runway because we it's just a tutorial, and we will do a standing takeoff. So we will stop, spool up the engine to 70% and 1, and then push the toggle switch on the throttles. The toggle switch is on the screw, in the flat panel, so the 2D cockpit, in the 3D cockpit that I will show you later, where the takeoff go around button are actually located too. We're just moving at 24 knots, we have to slow down a little. Before takeoff checklist is complete, and we're just missing the landing lights. Yeah, it's a long runway, I know, actually it's 3,500 meters or something like that, and we have just to the other end before, but don't worry, we have plenty of fuel to go around. With a full fuel load, so you will have a pretty long range of moving. Actually, I think the range is around 7,000 nautical miles with all the fuel. Now let's backtrack, so let me concentrate on the bird track. One moment. One information for you, it's better to actually turn 180 under 10 knots, just like in the 737, to prevent any damage to the tires, because one of the most hard things the tires have to do is a steep turn with high speed. So actually it's better to have a slow speed and turn slowly into the runway, in this case aligning with their main center line. We are now trying to align. Anyway, don't be so important about aligning perfectly in the center line. You want to have the vast majority of the runway in front of you, so just let the line to the aircraft, more or less. Okay, now we are waiting for our departure, and I will set up our engine failure, because after takeoff I want to show you an engine failure, and we will just take off, go around, turn around. You will see me moving the knobs, but probably I will not talk so much because the sounds will be pretty heavy in the cockpit. I know that. I'm sorry for this problem. I didn't find a way to improve my sounds on the microphone. Anyway, I hope you will enjoy the flights itself, and you will have also a briefing for the approach probably later into the flight. Okay, at this point we can set up the failure first of all. just to show you. We can select the parking brake a little a moment. We can go there to show you the failures. For example, we can go there. We can go menu, Simo, failure, add or clear failure. You can go to engines, I think. Oh, fire protection, that's fine. Engine 1 fire, we will use engine 4 fire. Engine 4 fire in 2 minutes. And we can go to the menu and return the CM. Okay, CMC is set. We can set also the weather radar for if needed. For example, week's turbulence and tilt +4 for takeoff. This should be fine for the departure. Now we set up the weather radar so we can return to the main panel and start the rollout for takeoff. So we can disconnect the parking brakes, spool up the engines, and pressing toga. Engine is accelerated now, throttle reference indicated in FMA. Keeping the center line while accelerating, speed is alive, thrust is set before 80 knots, hold is indicated in FMA, 80 knots checked.
V1. Rotate.
Rotation. We have positive climb, so please set gear up. Gear is set up. And nav is automatically connected 400 feet. Please select the command line. And we are now on autopilot. The autopilot is changing in throttle reference and VNAV speed, and keeping V2 +10 as you can see, 165, and flying out from the airport. As you can see, actually the airplane set 170, that is V2 +11 in this case, and we are just climbing out from the airport to the right heading 175 degree. Indication in FMA is throttle reference LNAV VNAV speed. At 3000 feet from the ground it will change in actually in acceleration mode to actually clear the aircraft and make it clean. At 3000 feet, 3,300 acceleration to 235 knots, correct. The mode changes in climb, active limited climb. And during the acceleration, we have now the fire warning, as we have said before, so we can clear the alarm and try take the QRH for the procedure. First of all, wait for flaps 5 just to clear the flaps 5. We can select engine display to see what's happening. We have process standard, so we are fine. Selecting flaps 5 now, and we have the first point for the QRH fire warning procedure is thrust level to idle and fuel control to cut off. Thrust level to idle and fuel to cut off. At this point, as you can see, engine 4 shut down, some information for the departure, flaps 1, clearing the aircraft, and then we have to take the fire switches and turn to A or B to release bottle. We go to the main panel. Engine fire is now out and we are engine 4 shut down. Flaps up please, and flaps up selecting, and we can set gear off. At this moment we have finished the procedure for the emergency. The fire is off. We check out the bottle. The bottle should be discharged. As you can see, like bottle be discharged. This means the aircraft has now cleared the bottle and we have to check message show not checked, so no need to release the other bottle. Vibration seems fine, we have no vibration, so we have not to slow down the aircraft. Next point is TA array to TA only selected. And the next procedure is land as soon as possible and do not perform engine shutdown checklist. So we have finished the fire checklist. To show you the performance of the iFly 747, we will just modify our cruise altitude to 10,000 feet. Just to show you, you can insert a new altitude by the knob and then pressing the knob with the left button. Actually, it changes the profile and the top of climb of the flight. As you can see, top of climb, top of the shot. We are now out from the clouds and from the rain. We can deselect the lights. Wing off. And the next one is actually selecting standard. I got this wrong because I said transition altitude to 18,000 feet. The transition altitude in Porto is 4,000, so we can 4,000 standard on both sides of the aircraft. So you can see now we are standard. Anyway, the QNH was 1013, so we don't have a big error actually in keeping them. After takeoff checklist is landing gear up, flaps are up, and auto brake off, landing lights off, and altimeter to standard. This completes after takeoff checklist, and we are now approaching our cruise altitude of 10,000 feet. The aircraft will actually modify its path. You will see we'll keep speed, LNAV and VNAV path, decreasing the vertical speed and leveling off at 10,000 feet. Sorry. We are now inbound to a left pump with one engine out. As you can see, we will not relight the engine after a fire. We will leave the engine like that. So turn it off, and we can now check out all the systems and what we have to do without an engine. Anyway, with the redundancy, probably with just an engine, we don't have any problem in keeping all the flight controls working. So if, for example, we can select the stat page, you will see a status message. It is bottle low, bright engine. Of course, because we have used the bottle, so it's low, that's fine, and we will need the maintenance to check this message when get back from the ground. Electrical, you can see we have lost the 4 generators, so the bus number 4 is powered by the other 3 generators with the cross connection, and in this case the SSB is closed, so all the generators are cross coupling the loads. They are actually paralleling the load. To make this possible, actually the generator must have a correct output, and usually when we have the correct output, we do have the generator that controls themselves with a load controller that controls which generator must speed up, which generator must speed down, and keeping the loads shared between the 3 generators. Then we have the fuel. As you can see, engine number 4 is stopped. The fuel pumps are working just for the 3 engine there, and if you can see, actually everything is working fine. Engine bleed air number 4 is disconnected. As you can see, just number 3, and all the pumps are working. Hydraulic system, we are using the demand pump for engine number 4, and the ADP pump is now disconnected automatically when we actually pushed the fire switch. Doors, of course, are closed and the gear is fine. We can return to the engine, and as you can see, we are out from the clouds, turning inbound. The next waypoint, it is Papa Romeo 611 on the arrival, and now we are again near the cloud stop, so we are losing some visibility, and we will now continue the flight towards our arrival. We have an FMC message. We set MCP altitude, of course, because we are approaching top of the shell. We can select 2400, that is our ILS glass lobe capture altitude. And if we go to the next page, you can see we have changed before. You didn't see those, sorry. Charlie India 17 set on 24,000 because we need to be at 24,000. Before was 2,400 feet or above. Now we are just at the same altitude, and that's fine. We now can go back to the cruise page, top of the shell in 5 nautical miles, you will see actually the deviation guide being indicated here, and also some other information about the addition on the vertical speed indicator. We can select, for example, the weather radar. We have selected different. If you select the weather radar in FS9, of course you don't have any return, but you have indication of the tilt you selected, and you can actually modify the tilt to 0. We will left it +1, and we express turbulence is fine. And as you can see, now we are in descent phase. We have also the. You should actually complete the forecast page before the start of the descent. Anyway, our transition altitude will be level 50, so we can select 50 as the transition level. And now, as you can see, the CDI is here. Those 2 points are actually the speed down points for flight level 100. The first one is when the FMC commands 240 knots. The second one is when you reach 240 knots. In this case, we are flying at flight level 140, so this distance is standard. It's not calculated directly from the FMS, but is just showing a standard possible altitude. Another data you can actually show on the handy is the terrain display. You can select the terrain, and if you are low enough, you will show also the sea level and the blue dots for the sea. You cannot select the terrain, it's not needed in this moment. And as you can see, we have a lot of clouds around, a sea of clouds around Porto. In a few seconds we will start our approach. I will now go for a standard briefing for the approach, also for the engine out. We will talk about the briefing itself, and then we will be back right here and finish the procedure for the set up the aircraft for the arrival and for the landing. In a few seconds, actually, I will not skip you any passage. We just pause the simulator to the briefing and then get back to the simulator to show you the arrival phase of the landing into Porto. Okay, welcome to the landing briefing. In front of us there is the standard standard arrival route for Porto. Again, we will follow a LPPR 8 mic arrival to runway 17 ILS. We will join the procedure directly from LPPR, direction 024 degree to Papa Bravo 611. The minimum altitude on this flag is actually 4,000 feet. Then we will turn to the right, 083 degree, 4,000 in the minimum route altitude, and Papa Bravo 671. At this point we will turn to the right and descend to 3,000 feet inbound Udrum. At this point we actually expect to maintain heading 173 and receive the clearance to descend to 2,400 feet. That is our glide slope capture altitude for the final cut-through approach into Porto. Again, we have an NDB 327.00 for Papa Oscar Roma NDB, and we have again the VOR Papa Roma Tango 114.1 in Porto. Clearance limit is for 3,000 feet. Probably we will be given a different clearance when turning into final. As you can see here, the MSA in this case will be 2,600 feet, and we will keep 2,600 feet until the final approach. In case we are asked for holding on to Porto 3,000 feet, and heading is inbound 173, outbound 353 of course. Again, transition altitude 4,000 feet, transition level by ATC. Airport elevation again 277 feet, and now we can move to the ILS chart. Here we are, ILS chart, category 2 ILS 17. There is an indication missile approach climb gradient minimum 4.9%. We have checked with the performance and that's fine for the 747 without an engine. We are just a little bit over this, so that's fine. Again, minimum safe altitude is again 2,600 feet. We will join directly and shoot directly from DME 12 from Papa Roma Tango at above 2,600. Then we will join the ILS at DME 7.6 for on the ILS. and then we will join the glide path that is 2.7 degree, not the standard 3 degree glide path. Is 2.7 degree on direction on heading 173, and descend until to the minimums that are actually 100 feet decision 8 or radial altimeter 108 for all the categories. In our case, we will do a land free, so we don't need a decision 8, but as a crew we decided to set 200 to be sure to see the runway before going for the approach, as we have just 3 engine, and so we will need, in case of a go around, more time to accelerate the aircraft and actually pitch up. Missed approach is pretty standard. Climb straight ahead to 3000 feet to Xapim, that is straight in front of the runway, and holding. So in case when we will join the ILS, we will just turn the altitude window to 3000 feet and continue the go around in case we are going to go around. ILS is 109.90 is the frequency, and the heading direction, the lock direction is 173 degree. Runway 17 elevation is 151, and this is pretty different from the 217 feet of the airfield, so we must note of this value. And when we will land, we expect to land immediately on the runway 17, and going around, as you can see, we will just exit the runway from one of those 3 taxiways, so Delta, Charlie and Bravo. From the performances we are calculated from TalkPack and from the computer, we just think to leave the runway on Charlie, and in case we just can get on Charlie, we will go to Bravo. Usually the standard exit procedure is Bravo and Sierra 1 to the stand Sierra 1-2. Anyway, we'll just probably leave the runway on Charlie. Again, this is the main airport chart, nothing special. Landing on 17 and left to Charlie. Again, parking. We have an engine out. We want the firefighter service to check out the aircraft and for any leaks, so we will clear the runway on Charlie, turn on Sierra 2 towards the stand and stop at this position, waiting for the emergency service to join the aircraft. This is everything for the landing briefing. We will now calculate the landing weight, set the VREF and V approach speeds, and set the auto brake selector that we will keep on auto brake set 2 because we calculated it's fine for the runway. So back to the cockpit. Okay, here we're back. As you can see, we have just started descent. The aircraft has commanded vertical speed. At the second point, we have the deceleration to 245 knots. After the briefing, we have to select the approach speed. We expect to have 98.8 of fuel during landing, so 98.8 sum with the zero fuel weight that was 178.9 does give us a 277.7 landing expected weight. So we set 277.7 into the approach ref page, parsing the init ref. You can set gross weight. You can see flaps 30 151, and we can select flaps 30 151. Wind correction for an outline is usually standard 5 knots, and so we left 5 knots. Then we can go back and set the auto brakes for the landing. We expect a landing with auto brakes 2, so auto brakes 2 selected, and we check this no smoking and seatbelt sign are off in on position. At this point, as you can see, we have now descended into the clouds, no visibility, but we will start also to have some rain later on. Descending through flight 100, we can select the lights for the approach, so runway turn off and landing lights on. Those are the strobe lights, and wing lights off. I get the arrow before selecting wings, the correct one. Although already is ready for the arrival, we don't need just to select the speed brake to arm before the arrival and stop the aircraft by selecting the various flap speeds and everything else. As you can see, during the descent in a VNAV path, the speed is not controlled by the FMS. As you can see, there is hold. Hold means that the pilot have the controls on the throttles. So you can, in this case, we are just slowing down too much, and after you lose more than 50 knots from the commanded speed, the auto throttle modes change to speed and actually automatically connect the throttle to the system to gain again the speed. If you stay on the speed, on the desired speed for more than some seconds, actually, it changes the gain on hold to keep the VNAV path plan for the arrival. As you can see, we are in the path completely and perfectly. We are now decreasing the zoom to show you the arrival. This whole point is actually this point where the FMS command the flaps up speed, and then every time you select a new flap speed, a new flap selection, it will just go to the next flaps placard speed, and you will see in a few seconds what does it mean. We are now in all the game. We are just a little bit high on the path, so we open the speed brakes, as you can see, and we gain again the path, and we can deselect the speed brake. The speed brake now we are back into the path, as you can see from the CDU. For the arrival, you must keep approach ref page on the left and legs page on the right. We are now descending. If you want to command a lower speed during the descent, you can press the YASMAC and select the speed you prefer. In this case, we can slow down to the up speed before the acceleration point if you need it. And this is done actually by pressing and using a override YASMAC for the VNAV descent. Actually, it can modify the climb path, the descent path, and it can actually mess up the approach, but you can actually apply some restriction using VNAV path using the speed. In this case, as you can see, we have selected the speed, so the path changed to VNAV speed, and so it's not following anymore the CDI. If we return this to automatically connected, you will see we will revert to VNAV path. Now we are passing flight for 500, so we select again start. 1013, we are now past the transition level, the same for the right side of the aircraft. We are now, as you can see, turning to final, and we are going to keep the deceleration point in a few seconds. We now continue descending. We will arm now the approach in a few seconds when we arrive near the we can give some thrust to keep the shoot, and we can select no more. We can revert to vertical speed and select the first flaps 1. As you can see, flaps 1 selected, speed 211 selected, and we can also select the approach mode with glide slope, arm, and localizer capture. We can now select again to flaps 5, 190. We can arm the speed brakes now. Speed brakes are armed. You can see speed brake arm on the upper view, so we can continue the slowdown. The next flaps selection. Okay, 1000 feet to the 2400 feet. We can set left flaps time. The flaps are, as you can see, the yellow is the caution range. Anyway, we are now selecting flap stand, and we are just going down to the right one, to the right speed. If we're speeding down, we can gear down, set the gear down to speed up the deceleration, and we are now completely on the lock, waiting for
2500.
Gear is now green light, and we can now select flaps 20 and the speed for flaps 20. We are now near the glide slope. We can select flaps 30 and the approach speed of 156 knots. 156 knots selected, leading is 175 for final approach, 24000 for the glide slope, and we are now going to intercept the glide slope and the localizer and land on the runway 17 in Porto. Before landing checklist: speed brake armed, gear is down, flaps are 30, and glide slope is captured. Now that the glide slope is captured, you have to select the go around altitude. In Porto is 3000 feet. 3000 feet set on the altitude window. Auto brakes are 2. Sign is okay. Cabin is prepared and ready for landing. We have some wind coming from the right with an engine out, so you will see all the aircraft aligning at the end of the approach. but we are now approaching the runway pretty nicely. You can check command, speed, log, glide slope, everything set, 156, 3000 feet, and we are fully aligned on the glide slope. As you can see, the localized area is just a little bit to the right because we have an engine out and also a crosswind component, but you will see at the end of the arrival the aircraft will perform pretty good even with an engine out. This is just the real one working, so you just stay on the side because he needs to align at the end of the approach. At 1500 feet with an outline, you will see reverting to land free mode. Yellow bar, everything is checked. We have rollout and flare modes armed down, and we are now ready for the landing. We can select the terrain or not terrain around, so we can get it out if you need, and everything would be pretty nice and automatic during landing. After the touchdown, you can select reverse manually. In this case, we will use just idle reverse, so just keeping the reverse to the green at 25%. As you can see, go around mode is now armed, and we are ready for the landing. ...800 feet to the runway. We have no decisions altitude because we have to select the radio. Of course, we don't have any decision aid, but we will leave 200 feet for radio just for reference. There is really bad weather here. Anyway, 600 feet. $400. $300. Lights, and we continue approach. As you can see, the runway is on side, and we are now approaching the runway.
Minimums.
Landing. Feet, keeping more or less the center line. We're just on the left is normal because we have an engine out. Anyway, the aircraft will fall out with a flare is on.
20. 10.
Touchdown. Rollout mode armed. Reverse. Set on idle. The aircraft is speeding down. Auto brakes are on. Speed brakes are up. And we are slowing down towards 100 knots. 100 knots, 90, 80, 70, and we can select reverser off, and we can disconnect the autopilot. Autopilot disconnected, auto brake disarmed by manual the press of the brakes, and we will continue towards the next end of the runway. We will leave the runway from taxiway Charlie as expected in the briefing, and then we can select flaps up and speed brakes down. Flap selected up, speed brake selected up, and we can leave the runway now. Leaving the runway, please select the landing lights off. Lights off, taxi lights on, and strobe lights off. TCAS TA array was in TA because of the engine fire. We can select altitude off. I just stopped. We are just exiting the runway. I was expecting because we have just 3 engines, so we can just pull up a little bit the engine to get back taxiing, and we will leave the runway. We can now stop to wait for the emergency services to get here and actually stop on taxiway, stopping the aircraft and shutting down the engines. We'll just clear the runway. And we will stop just on the main taxiway. So we'll turn right and then wait. Parking brake set, and we are now stopped on the taxiway to wait for the emergency service, and we can now select auto brakes off, taxi lights off, and we are now wings lights off. We can now select the engines off. We will leave just. We can select all the engines off, of course. And we don't need the we don't have the EPU on for this moment, but anyway will not be a problem for the shutdown, so we can shut down all the engines. The right side of the aircraft is off. This is just because we don't have the EPU turned on. Don't worry, this is fine. And we can now select the beacon lights to on. This is beacon lights off and left lights, keeping them on. This is actually shut down now. At this moment you should perform the normal shutdown checklist. Is pretty well explained into the Preflight Procedure. It's straightforward, nothing to explain, and so we can leave the tutorial here. I hope you enjoyed the flight, the small landing, the small flights and everything else. As you can see now, we have lost the power on the right hand side. This is fine and normal because we don't have the EPU. At this moment you should actually turn off all the fuel pumps, all the hydraulic pumps, all the electrical system, and then shut down the entire aircraft. But actually we had an emergency, so we just leave there, and then the pushback tag will get us into the stand as expected. Thank you very much for watching. I hope you enjoyed the flight and the preview of the 747. There are many more features to be discovered into the 747 itself. You will find it by yourself by reading the manual or flying after the release. Again, I'm sorry for the bad graphic. Probably I will do any other tutorial, and of course, if you want, you will find this link probably in the iFly forum, or anyone into the directly from YouTube. If you want to see something else of the, working of the iFly 747 before going to buy it, just put my comment on the YouTube video, or just pick up a post into the forum where I actually put the link for the video, and I will try to do a video of the feature you want to see as soon as possible. Only thing is that probably I will get some time to prepare them. Anyway, I will try to help you. Last thing I want to show you, I actually forget about it. As you can see, work temperature is now high, is 200, around 2 means around 200 degrees Celsius, and the pressure is raised because the temperature of the tires actually increased, and so also the pressure. And this is actually a model. If you remember, it was 213 before the flight in all the 5 landing gears. Thank you very much for watching again. I hope you enjoyed again. For the 4th time I was saying that, and I'm sure you will love the iFly 747. See you on the skies and have good landings.